The greedy algorithms are it's not one algorithm, it's rather a class of algorithms. It's a name given to a particular kind of algorithm which we'll study. The kind of problem that greedy algorithms solve is called optimization problems. Optimization problems are problems where you want to minimize or maximize something. You want to minimize wait time, you want to maximize your profit, you want to find the shortest route between two cities, or you want to make change for n cents with fewest number of coins. So for example, if you're a cashier and if you want to use as few coins as possible and make change for n cents, for example, let's suppose you had to make change for 15 cents, and let's just get you acquainted with the terminology of cents because your books uses that terminology. So 100 cents makes $1. 25 cents is a quarter. 1 cent is a penny. 10 cent is so this is a currency note, and the rest of these are coins, right? And the idea is to use as few coins as possible. So let's just finish this list. 10 cents are dimes, and 5 cents is a nickel. So pennies, dimes, and nickels and quarters. These are the kind of coins that you have access to. So the problem, let's suppose as a cashier, you might face what's the fewest number of coins that you can use to make, let's suppose, change for 12 cents. And that's easy to see. It's just use 1 dime plus 2 pennies, and that's the shortest number you have. That's the fewest number of coins that you have. So this is number of coins that were used were in this combination were 3. Let's suppose you had 16 cents to make. Then you would use 1 dime plus 1 nickel plus 1 penny. And that gives you, again, 3 coins. I'm already using in my mind an algorithm called the Cashier's algorithm. And the idea is the following. The idea behind the Cashier's algorithm is as follows. The idea is use the biggest possible coin at each step. For example, let's suppose I had to make change for 32 cents. What's the biggest possible coin that I can use? The biggest possible coin is, of course, 25. So I used 1 quarter, and then I check how much change I still have to make. So 32 minus 25, I still have to make a change for 7 cents. Again, same idea, use the biggest possible coin at each step. The biggest possible coin that I can use now is a nickel, so I choose 1 nickel, and that brings me down to 7 minus 5. I still need to make 2 cents. At this point, the biggest possible coin that I can use is a penny, and so I use 1 penny first, which brings me down to 1 cent, and now I take 1 penny, and that brings me down to 1 cent. So this is the idea behind the Cashier's algorithm. The Cashier's algorithm, although it works, but it works for a particular set of coins. So if, for example, let's make another set. Let's suppose I did not have access to nickels. Let's suppose I only had pennies, dimes, and quarters. In this case, if I try to make change for, let's suppose, 30 cents using my Cashier's algorithm, Cashier's algorithm would tell me to use biggest possible coin at each step. Well, the biggest possible one that I can use, this is 1 cent, this is 5, so this is 10 cents, and this is 25 cents. And so the biggest possible that I can use is of course a quarter, so I use 1 quarter, which leaves me with 30 minus 25. I still have 5 cents to make. But the problem is I don't have a nickel. So the biggest possible coin that I can use now is a penny, and notice that I would need 5 pennies. And in this case, I would have used a total of 6 coins. Is that the smallest number of coins that I could have used? No, there exists another possibility. If I had just used 3 dimes, then I could have gotten a change for 30 cents in 3 coins, just a total of 3 coins. So the cashier's algorithm only works when you have pennies, dimes, quarters, and nickels. It won't work, it won't give you the optimal solution, that is the minimum number of coins, if your set only contains these 3 types and it doesn't contain a nickel. So with that. Okay, so let's go through cashier's algorithm step by step, and let's see if we can follow the algorithm. So let's read the algorithm first. The algorithm is as follows. It takes inputs are C1 to CR, which is value of denomination of coins. So C1 is, and these have to be written in descending order. That is, C1 is the biggest, C2 is the next one, C3. And so C1 for me is 25 because my biggest is a quarter. Then C2 is 10 cents. Then C3 is 5 cents. And C4 is 1 cent. So this is my quarter will now be C1, my dime will be C2, my nickel will be C3, and my penny will be C4. Okay, and finally my last input is N, which is basically my change that I have to make. So let's consider N is equals to 32. Let's say I want to use cashier's algorithm for N equals to 32. Okay, first step, begin the loop for I equals to 1 to R. So I start my counter, I equals 1. R over here would be the total number of coins that I have in my denomination. So I had a coin, quarter, dimes, nickel, penny. So R is equals to 4. And so I know that in this first for loop, my for loop for I goes from 1 to R. So I will start from 1, but it will go up until 4. So DI is then set, counts the coin of denomination of CI used. So in this case, my DI would be just D1, and I start D1 as 0. I'm assuming I'm a machine and I'm just following the steps. I don't know what I'm doing. I don't know what these numbers mean, but we'll just try to see how I find what I end up with at the end if I just follow these steps of the algorithm. Okay, so my next condition is check whether N is greater than and equals to CI. So N was 32 and CI, because I is 1, so CI is just 25 cents at this point, because CI is the same as C1 at this point because I is 1. And so I check whether N is greater than or equal to C1. That is, I check is 32 bigger than or equal to 25. It is, and I will enter this while loop. So now I have DI, which is D1, is equals to D1 plus 1. So 0 plus 1, because D1 originally had the value of 0. D1 now becomes 1. So let's store D1 somewhere. D1 is now 1. Moving on, N now becomes N minus C1. So I have a new value for N. I started off with 32. N now has the value 32 minus C1, which at this point is 25, and so my value of n is now 7. So n is 7 now. Okay, I go back to the loop and I check, is n greater than equal to C1 still? 7 is greater than equal to 25. No, I will exit this while loop and I will go back to my for loop and increment the value of I. I now becomes 2. N is now 7 and Ci is now C2, which is 10 cents. I check the condition again. I set D2 to be 0. D2 is set to 0. I check whether n is greater than or equal to C2. Is 7 greater than or equal to 10? No, I exit my while loop immediately. D2 is still 0. There was no change made to D2. That is, I did not pick any dime in this combination. I will move to I3. N is still 7 and Ci is now C3, which is 5 cents. I will set D3 to equals to, I'm following this step now. Again, I is 3, coming back into this loop. D3 equals 0. I check whether n, that is 7, is greater than or equals to C3, which is 5. This is true. So I will set D3 equals to D3 plus 1, which is 0 plus 1. D3 is now 1. And I get a new value for n, which is 7 minus 5 equals 2. So n is no longer 7, n is now 2. I finally move to I equals 4. N is now 2. Let's just separate these different places where I incremented the for loop. Ci is now C4, which is 1 cent. D4 will be set to 0 first. I will check whether at this point n is greater than Ci, that is 2 is greater than or equals to 1. This is true. So D4 will be 0 plus 1. D4 is set to 1. Then again, I will check, is 1 greater than or equals to 1? This is still true. So D4 will become 1 plus 1. So D4 is now 2. And at this point, I have finished my values of I. And now I have these 4 values, D1, D2, D3, and D4. And n is finally 0. That means I have made change for all of the n that I wanted to. What do these numbers represent? D1 to D4. Recall that C1, C2, C3, C4 were quarters, dimes, nickels, and pennies, which was 25 cents, 10 cents, 5 cents, and 1 cent. D1, D2, D3, and D4. D1 is telling me how many coins I used of this denomination, of this particular coin. D1 is 1. It tells me that I used 1 quarter. D2 is 0. That means I used 0 dimes. D3 is 1, which tells me I used 1 nickel. And D4 is 2, which means it tells me that I used 2 pennies. And if you recall, that's exactly what we did when we were using Cashier's algorithm. That is, I used 1 quarter, 1 nickel, no dimes, 1 penny, 1 penny. That means if you look through your Cashier's algorithm, let me just place this like this. If you go through the Cashier's algorithm, sorting them in descending order assures you're always checking the biggest coin first. This is the step where you're making sure this sorting that you're doing before you're entering them. C1 is the biggest one, then C2 is the next biggest, and so on. And when you start from I 1 to 4 or 1 to R, you're assuring that at every stage you're first checking whether you can use the maximum possible denomination or not. So this step, that is n, the change that you still have to make, if it's bigger than the denomination, the largest possible denomination that you have, if it's bigger, then use that denomination. Add a coin of denomination Ci. At this point, you use that coin and you subtract the value of that coin from the remaining change that you have to make, and then you go back and check whether you can still use that coin. When you're done using the coin that you have, you move on to the next coin, that is this coin that is just smaller than that one. And if you complete this algorithm, that will give you the change in the fewest number of coins as possible.